Good morning. Now I am going to take the second module. The second module is of machines. First of all, why the fashion technology students, why they have to learn machines? Machines is the major part in which the swing machines, all the machines have been mechanical machines and pneumatic, hydraulic, all the machines are replaced with an electrical machines. So we need to know about how the machines work. Generally, the electrical machines are of two types. One is generator, another one is motor. So in that there is a different types of classification based on the supply we are giving to the machines. That is, if we are generating a power from the machine, then it is called as generator. If you are extracting a motion by applying electric power, then it is called as a motor. So in what way the electrical machine is integrated with your fashion technology is that it is a thing, it is in which the swing machines or now electrical swing machines have been made. Inside the electrical swing machine, while comparing the conventional machine, what it will be there will be a bobbin pins, a cycle of rotary motion using a rope will be there. That is replaced with a motor. If you press that shaft, that will rotate, and you will be that will give a linear motion for the movement of the needle with the help of round and round motion of the motor. So the machines can be classified into AC machines and DC machines. In AC machines also generator will be there, motor will be there. DC machines also generator will be there, motor will be there. Okay, first of all, for knowing about the machines, we need to know about the how it works. There can be many machines, motors everywhere we are using nowadays, but that should be known how it works. So based on the principle of electromagnetic induction, it works. See, wherever you go, all the things will be of electromagnetic induction. For example, transformer. In everyday life, power is the main thing you are using. Without electricity, you can't live. So for generating electricity, you need a generator. For transferring electricity, you need a transformer. So everything is of a principle of electromagnetic induction. So what do you mean by electromagnetic induction? When electric field and magnetic field gets interacted, there will be a generation of voltage or force. So this principle will be applied in all your day-to-day life activities by the instruments you are using. Even hair dryer, everywhere there will be a motor will be there, drilling machine. In each and every application, there will be a principle of electromagnetic induction you can feel. So what is electromagnetic induction? As I said, it is the interacting of both fields which gives forces, or which gives a result as a force, or it generates voltage or current. Now a Faraday, a scientist, have given framed a law how the electromagnetic induction works and induction works. So he framed a certain law. There will be two concepts in that law. In the Faraday's first law, what is the thing is that when a current carrying conductor is placed in a magnetic field, an electric force is generated or a mechanical force is generated. So that's how your motor works. This is the first thing. The another concept in the law itself is that when you give an electric power and move the electric field in a constant magnetic field, what happens is this, a current or voltage will be induced in it. So when you give a mechanical force or magnetic, when you give a current through the coil in a stationary magnetic field, a force will be generated. When you give a current in a rotating magnetic field, when you give a motion in a rotating in a magnetic field which rotates, when you give a fixed electric field and your magnetic field rotates, that will also generate a current. So fixed magnetic field, movable electric field, force will be generated. Fixed electric field, movable magnetic field, current will be generated. So this can also be defined in an easy way, in which I am saying that there is a two loads. Load 1, load 2 is supplied through a battery. A wire is connected in this, battery is supplying a load. So in this we may consider, and we can take one magnet having north pole, and if this bulb These two, so two loads, as I said, we can consider as an electric bulb, is connected through a coil, copper coil. Generally wires are made of copper. So it is a copper is of conducting nature, it is a current carrying conductor. When battery supplies power, a current will be flowing from, when see here, from here load 2 is there, so current flowing from load 2 to load 1. When I am supplying current, this will be, if it is of low voltage, this will be of dim. Okay, that is how it operates. But what happens here when you bring a magnet towards the coil? What is the change? What is the effect of magnetic field on the electric field happens? Because magnetic field also will have flux, magnetic flux. Electric field will also have electric flux. These two flux gets interacted and provides a force. These force gets interact and generates a force which moves the coil. So that is the principle used in this. In the Faraday's law, when you bring the magnet like this towards the coil, your coil will be bending upward. Why does it bend upward? Why it should bend upward? Why it should bend downward? When you bring the force, when you bring the magnetic field towards the electric field. See, this magnetic field and electric field gets interacted and generates a force, as I said. When you remove this, when you keep a distance, the magnet away from the coil, it will be behaving in the same manner. It will reform its original form. It restores to original form. What happens if you reverse the magnetic field? If you reverse south pole and north pole, what happens? If you reverse the field, your coil will be bending downwards. So the direction, when you give north pole and south pole in the same way, it will be in upward. When you reverse the direction of the poles, it will be in the opposite direction. So this is how the Faraday stated, when a current carrying conductor placed in a magnetic field experiences a force. Current carrying conductor placed in a magnetic field, it experiences a force. The next thing is Fleming's left hand rule. The Fleming's left hand rule is that by applying this left hand rule, we may identify the direction of current, direction of force exerted by the coil and the direction of the magnetic field. Let us apply Fleming's left hand rule in this picture. How to apply Fleming's left hand rule? So stretch your left hand in a left hand fingers, 3 fingers, thumb finger, forefinger and middle finger in a 3 perpendicular direction. If you keep like this, see, I am keeping in the same way. This thumb finger, forefinger and middle finger. Your middle finger points towards the magnetic field. We have to stretch the left hand in a perpendicular direction. Here, your middle finger points towards the flow of current. Your forefinger directs the direction of magnetic field, and your thumb finger shows the direction of conductor. When your current is flowing in this direction, but your current is flowing in this direction. So if you keep like this, your current will be in this direction, your magnetic force will be in this direction, and your thumb finger will be in this direction. So this is how we are applying the Fleming's left hand rule in the identification of direction of current, force and direction of magnetic field. So this is how we are applying this. See, note down that the thumb finger points towards the force, forefinger towards the magnetic field, and middle finger towards the induced current or voltage. This is how your Fleming's left hand rule is applied. Similarly, your Fleming's right hand rule. The same thing, but in the Fleming's right hand rule, as I said, Faraday states 2 statements. When a current carrying conductor placed in a magnetic field, it experiences a force. And the other thing is that when a electrical supply, when a rotating electric field is placed in a magnetic field, it generates a voltage. So you need to identify the principle that will be used for generator also. This thing will be used for motor and this thing is for generator. So Fleming states that is a motor rule and right hand rule as a generator rule. In generator rule, in the same way, if you apply the middle finger points towards the direction of induced current, and forefinger points the magnetic field, and thumb finger points the direction of motion. If you rotate the conductor in the magnetic field, what happens is that the current will be generated. So this rule is defined as generator rule, and that rule is defined as motor rule. So there is another statement states that a Lenz's law. Lenz's law states that what he is stating is that the magnetic flux, which is the induced EMF which is generated by the magnetic flux, opposes the direction of the magnetic field. There will be a magnetic flux which is cut by the motion of the conductor, that will generate induced EMF. That generated induced EMF will be opposite to the direction of the magnetic field that is generated. From this statement, we can identify that the generated induced EMF is opposite to the direction of the magnetic flux which produces it. So based on these principles, our motor is constructed. So let me come into our part. What is the construction and working principle of DC motor, single phase induction motor, and AC and DC servo motor? These are the motors which we are using in your day-to-day life. Here the next part is that DC motor. See, DC motor, in the sense you are giving a DC power to the motor. By placing it in the magnetic field, your coil will be rotating. If that is rotated, that shaft will be rotating. From that you will be rotating the load. So likewise, if you give a DC supply to the swaying machine, if you press the pedal, it should be rotating. The motor should be in on condition. It will be rotating continuously. So there will be 3 linear motions in swaying machines that we will be studying in your later theory parts. So DC motor. Now we are going to see the construction of DC motor. DC motor has 2 parts. One is stator, another one is rotor. The stator and rotor, what is the thing is that stator is a stationary part. Stator is a stationary part and rotor is the rotational part. But we have to define the stator parts and rotor parts. Say generally if you see a motor, it will be of a spherical in shape. Inside it there will be a coil will be there. We know that in every motor there will be a coil. So we need to identify what is the stator part and rotor part. The stationary part is that it is of field winding will be there. Let us speak from the outer to inner. The outer portion which is covering the motor is called as yoke, which protects the motor from the mechanical shock, that is from the outside vibrations or some other thing which is disturbing the motor, like environmental conditions, dust particles to accumulate inside the coil. So to avoid that, yoke will be used. The next is next to the yoke is the field winding and field pole. There will be for a DC motor, what should be there? Magnet should be there, magnetic field should be generated, electric field should be generated. For providing the magnetic field, a magnet will be present. That is called as field pole. In that, there will be a coils will be wounded on that is called as field winding. So that will be like a pole shape. So we will say in this region is called as pole shoe. Why it is bended is that to provide a maximum gap between the motor and between the pole magnetic field and the electric field to expand the flux. If the flux flow is high, then the generated force is also be high. The flux is directly proportional to the force. The next part is the armature. That is that armature is nothing but coil. What is the major part is that coil. If you supply power to that coil, electric flux will be generated. To that, because of that flux, magnetic flux will be generated. The magnetic flux already present in the field gets entrapped and provides a torque which experiences the armature to rotate. So in between the shaft will be there. From the shaft that will be connected to the load. Why the interpoles are present is that when there may be a reactions, a certain set of reactions, they will say armature reaction. Because of that, the flux losses will occur that will result in a failure of the motor. To provide the from the failures, interpoles, laminations, these things will be done. So next part, the important part in the DC machine is the commutator. and commutator segments. Commutator is nothing but you know the terms of inverter, rectifier and all. The commutator is nothing but it converts, generally in DC machine the generated power will be of alternating one. To convert that into a direct, we are keeping a commutator in DC generators. In DC motors we have to provide supply to the motor, so that should be converted to DC. That will be converted to DC. So commutator will be present and brushes will be there to avoid contact with the electrical loads. So brushes will be there. So because of the presence of brushes, the motor should be repeatedly keep on maintaining, a maintenance period should be noted because of its wear and tear. Once the brushes have been teared out, then there will be a problem to the motor. So this is what the construction says. The main part is yoke, field poles, brushes. So this is how your motor surface will be there. Inside, if you open the motor and see, you may say this type of structure. This is a cross sectional view and this is the real construction of the motor. So you would have known the yoke that everyone would have seen. Next, the field winding, that is on the magnet coil will be wound, and this is armature. The multiple number of coils will be rotated through the shaft, and this is commutator will be fixed attached to the armature itself, that will convert AC to DC. So this is how we are, if you open and see the motor, this is how it will be looking like. So why we need to know, we need to study the construction of motor. As I said, for your application it is required, how if the motor is failed, we have to study the performance of the motor. Next, you see types of DC motor. There are different types of DC motors present in the DC machines. First one, DC series motor. Second one, DC shunt motor. Third one, DC compound motor. See, in DC series motor, shunt motor and compound motor, the construction is based on its field winding is wound on it, how it is wound. So there will be of two major types, self-excited and separately excited. The self-excited machine is that the supply is directly given to the field winding and armature winding, only one single supply will be given. But in separately excited, the field winding will be given separate supply and the armature winding will be given separate supply. So this is the based on the excitation, it is classified into self-excited and separately excited. The separately excited DC machine is further classified into DC series motor, DC shunt motor and DC compound motor. So let us see one by one how the construction of DC series motor will be. Generally, the motor representation for DC will be like this. DC motor, phase neutral. So this we will call it as armature. And another one thing, field should be there. This is we called as field. For series motor, what is the thing is that the field coil will be series to the motor. This represents the brushes. If you didn't note this representation, then that machine will be called as AC machine. If this is present, then it is called as DC machine. To indicate brush, we are using this. Field winding, armature winding, phase. This is DC series motor. And this is DC shunt motor, in which the field winding and armature winding is parallel, that is shunt connection. Parallel, if it is in electrical, we can say shunt and parallel are synonyms. And compound motor, in the compound motor there is a two connection. long shunt and short shunt. The field coil will be of connected in a different manner. This is armature, this is field. Compound motor. Based on the connection of the field winding, it is classified into three categories. One is DC shunt, DC series and compound motors. Compound motor is further classified into long shunt and short shunt. Long shunt and short shunt motors will be used. So why these motors, each and every motor has different performance, but in the mainly thing is that in the constant field. So if we need a constant, if we are running a constant load of high power, we may go for compound motor. If we are going for a constant running of the motor without any changes, you can go for with the medium to low to medium power range, you may use DC shunt motor. So in DC series motor, you will be starting with initially a full load. In any other motor, you won't start the motor in a full load condition. Load is nothing but you will be giving a high torque to the motor. If that torque is balanceable, then your motor will be started rotating and it will be rotated, so that will be called as a load. So for DC series motor, maximum amount of load, if there is a load present, that should be of maximum range, maximum high level, it should be kept, and we have to start the DC motor. Because why the reason is that here the field coil current and armature coil current are directly proportional to the torque value. So this and this will be of equal. So if it is greater, what happens is that your torque should be high, or else what happens, your motor will run at the starting time itself, your motor will run very fast and it will go off. So for that you have to turn on the DC series motor at a very high torque. The next is the losses that occurs in the DC motor. Basically there will be a losses called copper loss, frictional loss, windage loss, hysteresis loss, eddy current loss, hysteresis loss. See, these two losses is called as magnetic losses. These two losses is called as mechanical loss. See, the frictional loss and windage loss is because of the brushes present in it and the air gap which we are providing to the field coil and the motor. If frictional loss occurs, that is, your brushes will be continuously in friction with the commutator and the load. So if it is tear out, where it and tear out has happened, it is teared out. What happens is that your brushes will be spoiled, and what happens, your motor will be failure one. So because of friction. So windage loss is that because of more air gap also, if the air gap is provided with maximum difference, what happens is your windage loss occurs. Because of the airflow inside that, your flux may also get lost. So windage losses may also occur. Eddy current loss is that your motor body will be in the body of the motor, a current may be generated due to the magnetic field, because all the elements are manufactured using a iron or steel. So that is a conductor. So that may generate a current flow in the body core. So that losses is called as eddy current losses. The next is the hysteresis loss due to the magnetic field always present in the motor. The next is copper loss. Copper loss is that because of the resistance of the copper material, there may be some voltage or current loss. So that may also affect the performance of the motor. These are the things which have to be known for the DC machine. So now we have seen the DC machines. In the next lecture, we may see the single phase induction motor and how it works. Thank you.